Quantum computers are a type of computer that use quantum mechanics to perform operations. They operate on the principles of superposition and entanglement, which allow them to perform certain computations much faster than classical computers. One of the key advantages of quantum computers is their ability to perform multiple calculations simultaneously, thanks to the principle of superposition. This allows quantum computers to quickly process large amounts of data, making them particularly useful for certain types of mathematical problems. Another key advantage of quantum computers is their ability to take advantage of quantum entanglement, which allows them to share information instantaneously across great distances. This makes them potentially useful for applications such as secure communication and cryptography. Despite their potential, quantum computers are still in their early stages of development and are currently limited in terms of their practical application. However, there has been significant progress in recent years, and many researchers are working to develop more powerful and reliable quantum computing technologies.
Okay, so quantum computers are a whole different type of computer than what we're used to. Instead of using regular bits of information, which can either be a 0 or a 1, quantum computers use something called qubits, which can be both a 0 and a 1 at the same time. This is called superposition, and it allows quantum computers to do multiple calculations at once. Another cool thing about quantum computers is entanglement. This is where two qubits can become linked together in a way that they always have the same value, no matter how far apart they are. This could be really useful for things like secure communication, because you could instantly tell if someone had tried to intercept your message. Now, the downside of quantum computers is that they are really complicated and hard to build. Plus, they can be pretty error-prone, because any outside interference can mess with the qubits and mess up the calculations. So, while we're making progress in quantum computing, it's still early days and there's a lot of work to be done before we see practical applications for it. Quantum computers require specialized equipment and materials to build. They use qubits, which are typically made from superconducting materials, trapped ions, or other exotic materials that exhibit quantum properties. These qubits need to be carefully controlled and isolated from the environment to prevent interference that can cause errors in the calculations. The actual construction of a quantum computer involves creating a series of quantum circuits that can manipulate and read out the qubits. These circuits are usually composed of specialized components such as microwave generators, amplifiers, and cryogenic cooling systems that operate at extremely low temperatures. Building a quantum computer is a highly specialized and complex task that requires expertise in physics, engineering, and computer science. While progress has been made in developing small-scale quantum computers, they are still in their early stages of development and significant technical challenges remain before they can be scaled up to larger sizes and put to practical use.